So now that we've gone over the trig substitution, the trig integrals, and the integration by parts, just a couple simple examples, we can do the partial fractions, the improper integrals, the stuff that we've been studying for the past couple weeks, right? Those past videos were just a review so that we could get to the bulk of what we've been studying, and that's because partial fractions, improper integrals, those all require that we have a robust understanding of the previous integration techniques. So partial fractions is basically just like all of these, an algebraic technique, right? We get fractions that are kind of dirty. We don't want to deal with them, right? We don't want to handle, right, large x to the fourth plus 2x cubed plus ... over an x cubed plus 5x, right? Those ones are kind of ugly, right? There's no good u substitution, and they're really difficult. So we have to figure out a way to reduce this problem into a bunch of easier problems. And that's like 90% of what mathematicians do, right? We want to reduce the problem into something that's way easier. So the best way to learn these partial fractions is just to do a bunch of examples, right? The book is going to lay out a bunch of cases, right? Case one is that there's specific denominators with linear factors, and there are techniques there that we have to take advantage of. But just doing examples of those problems, it'll be easier to get the hang of it because the cases are a little bit too general, at least for my taste. They might help for some people, but in this case, we'll just jump right into it and go into our first example. So here, let's take the integral of 3t minus 2 over, right, t plus 1. Now, we could maybe do a u substitution here because they're of the same order, but let's try it with the partial fractions technique. We're gonna, because our powers here are the same, right, we have to do the polynomial division, 3t minus 2, 1 plus t, right? This will just be a 3t plus 3, right? And remember, we're subtracting these, so these can go to 0. This will be negative 5. This will be minus 5 over 1 plus t. So we're going to have this integral, right? 3 minus 5 over 1 plus t dt, right? And now we just have a constant here and our function of t. We're going to separate those up. We're going to get the integral of 3 dt minus the integral of 5, 1 over 1 plus t dt. Now this integral is actually really simple. We just do a simple u substitution. U is equal to 1 plus t du is equal to dt. Right, so we have the integral of 1 over u du. That's going to be an ln, so it'll be ln of u, right, minus 5 ln of u, which is going to value it to ln of 1 plus t. And then R3, again, that's also going to be another simple integral. I'm just going to use the power rule. We're going to get 3t minus 5 ln of u, which would be 3t minus 5 ln of 1 plus t plus c. Right, and that's our final answer.